solenoid is 29.68 centimeters.
Keep going.
Centimeters long, has 359 loops, and carries a current of 6.87 amps. Find the strength of the magnetic field inside the solenoid. Show all steps necessary to prove solution. Hit see page 700.
Okay. Also, make your receipt. Don't forget to put your points in there, dear. Dang, you got a lot. It's almost like 30 more points. You got like a whole dude now you recovered. So look, what you need first and foremost is located on page 793. 792 gives you a little bit to read about what we're going to do in case you're curious about what the purpose of this is. So first, take these notes down here, okay? Everybody know what I'm talking about? On 793, there's a box here. You need notes in that box, all of it. You also need to make sure you use the same Greek letter here to get your full credit. You can't just put M0. You got to put mu, right? Type in your special character set MU to find that character. All right, while you all are doing that, I'm going to work through the problem a little bit. This is, of course, our reading section, right? Robotics, and we're dealing with something called the magnetic field. Right? You guys will be taking down notes on this. We saw a magnetic field earlier of a solenoid. You're going to see solenoids a lot often in robotics because they sometimes are the motors that turn the wheels and actuate the arms and stuff. So the equation is this. It's B, for our magnetic field, is equal to mu naught, right, multiplied by parentheses, N, as our number of loops, over L, right, multiplied by, outside of this is our I current. Now we've seen this before, so these are a little different. Okay? So now we have that, let's explain it out a little more. We know that this is going to be measured in terms of Teslas. This is measured in terms of a Tesla meter over amp. The length, right? That's the length of the wire itself. And when we're doing that, somebody else is calling, who's calling? When we're doing that, we got to keep in mind we have to use meters and not centimeters. So this is meters. You might have notes on this from last week. Amps is our current. You saw, and this is known as your number of loops. So that's how we break the problem down. Now let's do our known and unknown section. So what do we know? Well, someone can give me those values for 5 points each if they know. Unknown, what is the problem?
Solenoid is 20.
Solenoid is what?
24.89 centimeters long.
It's 24.8?
Yeah, 24.8.
Let me check that. I think my school is there.
It's like we right?
Yeah, we. So I'm trying to find the document. Alright, go follow which is. Yes, it's 24.8. That's incorrect. Okay. So 24.8 meters. 9. And what's that going to be?
24.89 centimeters.
Yeah, but what is it going to be up here? Which of these variables will let it?
Oh, that's meters, so you gotta change it, right?
Yes.
So that's
L is what I was asking you.
Oh, length, L.
And then, yes. Is equal to, he said 24.89
centimeters.
Go by your document, everybody. CM. Okay? That's M. And like Andy said, we got to change that because we cannot use centimeters. So how do we change that? You remember?
You divide it by 100.
Divide it by 100? That's easy, but there's another way to write that. Just simply times 10 to the 2. You try to do some advanced math. Technically, he's right, but I don't want y'all to get scared of some fractions, okay? So you just say 24.89 times 10 to the negative 2. I just said just divide by 100, which is correct, because that's a negative 2. I think this is easy punching the calculator. So, let's keep going. What else did we give? That was 5 points, Eddie.
Loop.
Loops, okay.
And that's
N.
N.
What?
N.
N. The N equals what?
275.
275 loops. Okay, and what else are we getting?
What else? I think that's about it. Oh yeah, amps, current.
Yes, I. Very good. So I is equal to what? It's
4.78 amps.
4.78 amps. Okay. I need that. 5, 10, 15, 20. Unknown. What are we looking for here? B. Who said that? Yeah, cool. B is measured in what though, man?
B is measured in Tesla.
Yep. Waiting on her. Teslas, okay? So this one is pretty easy because it's asking for B, and if you look at our equation, it's already set up for B. So we just plug in our numbers and say goodbye to this problem. So let's plug everything in slowly, right? So this is your first half of your problem. And all I want to do now is I'm going to say, hey, step A, it's only really one step, right? You're going to solve for your B field, right? Or Tesla's, your magnetic field. So to do so, let's use this equation, let's rewrite it. Oh, we forgot to mention one thing. The permeability of free space. That's your mu naught. You remember what that is?
Oh, mu naught is 4 pi.
There you go.
4 times pi times 10 raised to the power of -7.
Tesla meter over amp. There you go. So plug all, rewrite the equation as B is equal to, again, mu naught. You can use insert special character to find mu, which is mu, that's a Greek letter, multiplied by I, right? Plug everything in. So that'll be B is equal to, what was our mu naught? That was 4 pi, that's a pi symbol, times 10 to the -7, and this is a Tesla meter amp, multiplied by your N, top was 275 loops, right? Divided by our length, we can't use centimeters, we use meters, so that's 24.89. Use your fraction button for this one. And -2 meters, close, multiplied by, final part is your current I, and that's 4.78 amps. All right, somebody get 10 points if they can get the final answer correct. Grab calculator, see if somebody take a calculator. So if we go here, I got, boom, I'm gonna take my time and type it in. So parentheses, I'm gonna say 4 pi button is down there, get that, times 10x, and I put -7 in there, close parentheses from outside, so multiplied by, let's use a fraction here. So that would be, like I said, 275 divided by, we got 24.89 times 10 raised to the -7 come out, and multiplied by 4.78. So we get a syntax error on. There we go. All right, so who got it? If I got it, I got 1 to 10 points, and then I'll just write out what it is. Okay, I see no takers, so that's going to be 663.66. And it's measured in Teslas. So 663.66 Teslas. And that's all she wrote. Mr. Trust, you got 35 points. You can add your score. And hurry up and get the notes. All right, so that is it in essence.